Hey guys, Miss Fearing here. Today we're going to start Unit 2 and we're going to start by looking at graphing systems of equations. So our learning target is I can solve system of equations by graphing. So when we talk about a system is a set of two or more linear equations. When you see that word linear, it just means that they're in equations of lines. When I start asking for the solution to a system, it's the point where the two lines cross. So it's not enough just to graph them, you have to also tell me what the solution is. We have three different situations that could happen. We could graph these lines and have them cross at one point, like in this example here. If that happens, then we say it has one solution and we write what that solution is. So this would be over 1, 2, 3, 4, up 1. So the solution here would be 4, 1. We could have this situation, B situation, happen where they don't cross at all. Therefore, there are no solutions. If they don't cross at all, they're parallel lines and there are no solutions. Or we could have the C situation happen where it is the same exact line. They have the same B, the same M. It's the same exact line, and therefore it's infinitely many solutions. And we go ahead and rewrite IMS in those situations. So here's our steps to graphing systems of equations. Step number 1, graph the first line. Step number 2, graph the second line. And then step number 3, find the point of intersection or the solution. Remember, if they're parallel lines, they don't cross at all, so there's no solution. If it's the same exact line, then we write infinitely many solutions, or IMS. So let's go ahead and look at example number 1. I have y equals negative x plus 8 and y equals 4x minus 7. So I'm going to go ahead and graph the first equation first. So I'm beginning at my b, which is this is my 8. So I'm going to begin up here, and I'm going to move with my m. Remember, this is like imaginary 1, and I always can put a 1 under it. So negative 1 tells me down 1 over 1, down 1 positive. And especially with systems, we want to make sure that we do this the entire grid so that we don't miss out on the point where they could potentially cross. So there's my first line. So I'm going to go ahead and I'm going to graph my second line. So I'm going to start at negative 7, and I'm going to go positive 4 over a positive 1. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. I'm going to do this over and over again. So here would be my line. So then step number 3 tells me to figure out point where they cross. So they do cross, they cross right there. So my solution for both of these is going to be 3, 5. Remember the x before the y, so I went over 3, up 5. That would be my solution. So here's the second example. Graph the first line, so I'm going to begin at 6, and it's a negative 1 and a positive 2. So I'm going to go down 1, positive 2 the direction. I'm going to do that over and over and over again. I'm actually going to go up 1 and to the left 2 as well, so I can get all the way through that the grid lines. So I'm going to go ahead and I'm going to graph the second equation. So I'm going to begin in a positive 1, and it's the same kind of slope. So I'm going to go down 1, positive 2, down 1, positive 2. And I'm going to go the opposite direction just because we never know where these lines could cross. So in this situation, I have parallel lines, and I know that because the slopes are exactly the same. So I saw that kind of right away, but I wanted to graph and make sure. If the slopes are exactly the same, they're parallel, and then we go ahead and we write no solution. They do not cross at a point anywhere. So example number 5, I have Monica and Max Gordon, and they each want to buy a scooter. So Monica has already saved $25 and plans to save $5 per week until she can buy the scooter. Max has $16 and plans to save $8 per week. So the first thing we want to do is we want to write two different situations. We want to write one for equations. We want to write one for Monica and one for Max. So Monica has $25 in her account. That's the B value. That's what she's already has. And she plans to save $5 per week, When you see that per something, that tells you that has the variable. So there's my equation for Monica. I'm going to write one for Max. Max has $16, and he plans to save $8 per week. Again, that per week tells me I need that variable. So I've already set up my graph here. I put the number of weeks on the bottom, and then the total money we have on the side. I went up by 1s on the bottom and then 5s on the side. Feel free to change your scaling at all, but make sure you label it with whatever you have. So I'm going to go ahead and take a second here, and I'm going to graph these two lines out. Go ahead and pause the video and you try it as well. So here's the graph I came up with. When you are going to and graphing Max, just be careful. He starts at 16 and he grows by 8 every time. So since my scaling went by 5s, it made it a little funky, but I just did 16 plus 8 to figure out where I would be at, and then added another 8 to figure out where I would be at. So you can do that over and over and over again. So the first question asks, how many weeks will Monica and Max have saved the same amount of money? So the point where they cross is this point right here. And that actually ends up being 3 weeks in. And at that point, they're going to have this much money. So if I count up my scales, I get $25, $30, $35, $40 in their bank account. So at 3 weeks, they're each going to have $40 in their bank account. So for example number 6, we can do the same kind of idea that we've been doing. The issue is they're not in slope-intercept form, so I have to solve for y first. So in my first example, I have 2x plus y equals a negative 4. So I'm going to solve for y, or get the y alone. So I get y equals a negative 2x minus 4. So I'm going to start at a negative 4. And I'm going to go down 2 over 1. And I got to go the opposite direction as well to make sure that I don't miss out on the point where they could cross. So there's my first line. So I can do the same idea with the second equation. 5x plus 3y equals negative 6. Subtract 5x. So I get 3y equals a negative 5x minus 6. Divide everything by 3. So y is going to equal a negative 5 over 3x minus 2. So I'm starting at negative 2, and I'm going to go down 5 over 3. Then I have to go the opposite direction, over 3, and then up 5, over 3. It's a good thing I did that the entire way through, because they didn't cross until that last point there. So here's the point they cross at, which would be a negative 6, and then positive 8. So my solution would be negative 6, positive 8. So go ahead, try this one on your own. Pause the video, do your work, and then check your answer. So when I go ahead and did these, I ended up with the same exact line. So if you remember, if it's the same line, our solution we actually write out is IMS, infinitely many solutions. Your job now is to complete Unit 2 Practice 1. Go ahead and ask me questions if you have them.